We have Mark Callaghan up next, and he works with the very talented MySQL team at Facebook, making sure that Facebook is happy in with a very large MySQL environment. So please welcome Mark Callaghan.
So my topic is what comes next for MySQL, or my theme, but I have a very narrow focus. I care about large sharded deployments. I think there's other valuable and interesting ways to use MySQL, but I don't know much about those other ways. So that's my focus, and the approach is I will list problems that we confront today and that we hope to solve in the near future. A frequent question that we get asked is, why do you use MySQL? And the answer, I think, is fairly common for many of us. It was there when we started the job, or when I arrived at the company. It wasn't a choice that I made. The choice for us is, how can we make it better? And so the big focus is on scaling it, and I think we've done a pretty good job with that. We have a very talented team with a lot of room for new people. Continuing the thought of jobs, we have more problems than people. Definitely work that you will do will not have someone looking over your shoulder. The other point to reinforce, MySQL with InnoDB is web scale for us. Our peak or aggregate workload in production is about 60 million queries per second and 1.5 billion rows read per second. And while these numbers are big, our focus is on pushing back on the growth and reducing the numbers. So we could have, I don't think we've done a good job at making these numbers as big as they should be. So we've made it better, our deployment, and for us that means we're putting 10 times more data on a server compared to what we did about 3 years ago. And this wasn't done by buying expensive hardware or buying pure flash, which is an easy way to solve the problem. It was done iteratively by solving a sequence of problems. So we started with MySQL 5.1, and despite the slow start from that release, it's a really great piece of engineering. We implemented flash cache, and flash cache allowed us to use a small amount of flash on top of less expensive disk storage to run the same workload. The next point, we found and fixed a lot of stalls. That's usually the focus of my entire presentation. It's just one point here. We've been doing this for 3 years. The database performance team makes it very easy. They'll frequently just tell us, here's the problem, here's the thread stack. It's fairly obvious what's going on. Please fix it. Multi-threaded purge was a patch we got from Percona. This was a very valuable patch that fixed some performance stalls in production. A few outliers were so far behind in InnoDB purge that they were never going to catch up. As we fix these problems, the database operations team is continually deploying new RPMs, and change is frequent. So there's a lot of opportunity for mistake there. It's a very hard problem for them to deal with. Online schema change, we've been running schema changes continuously since writing the framework to do that. It's done to add covering indexes to fix performance problems and to keep up with the demands from the product teams. Recently, in the first quarter of this year, we deployed Faker, which is, I think, a joint effort between Percona and Facebook that allows us to prefetch the buffer pool ahead of the replication thread to remove I/O latency. And it's been a huge win for reducing replication lag. And then the final thing is we began to deploy InnoDB compression that Nizam spoke about yesterday. So we're doing write-intensive workloads on top of compressed InnoDB. Now, the general point I have, or part one of my points, is that MySQL has made amazing progress in the past few years official MySQL and the community have really done amazing work. Percona continues to give us patches that we need to get the full potential that we see from InnoDB. Monty Program has begun to do work on replication that we need. They've done a really great job with group commit. Continuant pushes forward replication. Codership does rocket science. I kind of understand the functionality. I don't really understand how it's implemented. And Facebook is also pushing and at times implementing improvements for MySQL. Multi-core performance used to be an issue. It's gone. Replication features that only were available in the past in the Google patch are now in official MySQL 5.6. It took a long time to get those features, but it's a lot harder for MySQL to implement something that's performant across a wide variety of workloads and portable than it is for companies like Facebook and Google to implement features only run within their data center. So I'm really happy and impressed by the work that they've done there. And performance monitoring, which is usually the source of efficiency gains for us, is now becoming viable for people who don't have a highly patched version of MySQL. But part number two is that a lot of work remains. A question that I frequently think about and talk about is there something better than MySQL or InnoDB? And sometimes that results in silly quotes on websites from esteemed database professors about our fate. And the good part about that is we end up making silly t-shirts quoting esteemed database professors, where the fate worse than death quote. I'm not sure if everyone's seen the blog post. The other good outcome besides the t-shirt is that I'm much friendlier with Mike Stonebreaker now. So he's a really nice guy, marketing his company. But then we have a serious conversation. At work, I have coworkers who ask me, can we do this? Can we do something better? And we are a big HBase shop. We have a lot of HBase expertise. So people who know HBase are helping us research the answer to this question. And at this time, I think the answer is still uncertain. But it's out there. It's something we have to confront. And the important, for us, the criteria are, is there something that uses less disk I/O, that does less random disk operations for the workload? Or is there something that uses less disk space? We're always pursuing things that are easier to manage in production because we have a lot more servers than we have people. We're trying to provide better availability. We want to improve the end user experience. And with modern hardware, we have performance capacity that the software that we're running was not written with 100,000 IOPS in mind, or with 24 cores or more on a server. And so we have a lot of issues to confront there. The big point, there's two platforms right now for database servers. Pure disk, or disk plus some flash cache, versus pure flash. And they require different optimizations. So if you're running a disk-based server, you want a database engine that reduces the IOPS load, because you have a lot of bytes, but you don't have enough IOPS for your pure disk server. If you're running pure flash, you want something that uses less space. So you probably want better compression. Because if you're running pure flash, it's likely that flash determines the price of your server. And an open question here, does one size fit all? Is there a database solution that works great on both? Update in place versus write optimized is an open issue. InnoDB is the update in place entry. And for write optimized, we have log structured merge trees via HBase, LevelDB. We also have FractalDB via TokuDB. The trade-off here, and I think the answer is unknown, is whether the additional reads that you're likely to do from a write optimized store, is that offset by the savings in random writes that you don't do. With a log structured merge tree, there's a read amplification factor that and they tend to use a Bloom filter to reduce this. And as far as I know, TokuDB is the only solution so far that eliminates the read amplification factor for range scans. It's likely that the answer in this case is highly dependent on the workload. So a lot of people will have a lot of benchmarking to do to figure this out. The potential gains from not doing update in place is that compression will be much better, and it's possible to make the I/O cost of maintaining a standby, that can be a lot cheaper. On the InnoDB side, it's here. It's stable, and it's awesome. So this is, I think, an open question still, but a very interesting question. Logical backup. When we run logical backup, and we like to run it, it accounts for more than half of the IOPS from that day on the servers on which it runs. So we want to make this cheaper. InnoDB does table scans in key order. Some database solutions have optimizations that allow you to do table scans in file order. So we hope to figure out whether that's possible. There's also a question about whether we can maintain an archive off of our transaction processing servers, keep it in sync with row-based replication, and have that as the source of backup. Compression. So compression can be a lot better with a write-optimized data store. And worst case InnoDB versus best case AltDB, which I will claim is representative of a write-optimized store, it's a factor of 8 when you're comparing uncompressed InnoDB versus, and fragmented versus the alternative. Now, a factor of 8 is a big deal if you're buying 8 times less flash to run your database. It's a really big deal. And if you could keep InnoDB defragmented, things would be better. Defragmenting InnoDB and compressing it, things are still better. But even compressed InnoDB without any fragmentation is 2 to 3 times worse than what the write-optimized store can do. And this is real data that we have in production, and it's representative of a lot of our data. So why is compression better? So for an update in place B tree, pages are about 2/3 full on average. InnoDB, when you compress a 16K page down to 5K, it gets rounded up to 8 kilobytes when written to disk if you're using 2x compression. So we're losing some of the compressibility from that. Per row metadata for InnoDB is larger. It's about 20 bytes per row in this case. And the compression window, which is the page size, for us is 16 kilobytes. And so a larger compression window would allow for better compression. Manageable and available. We talk about manageability versus availability, and for me, they tend to run together. So if we can make things easier for operations, then we're likely to reduce downtime. We need to make it a lot easier for our operations team to change things in place in production, because we don't want to have too much duplicate hardware to do the changes offline. We also don't want to impact the end user. With respect to manageability, we also need to make it easier to shift load between overloaded servers and underutilized servers. Pooling is a big issue of the last point. For our production servers, on average, we have a lot of spare I/O capacity. However, we also have too many outliers that are saturated and out of capacity. So the solutions in this case, resharding, I don't recommend it. You don't move users between shards, or you take one, from experience, I will claim that for a large and busy site, this is a 1-year project. The easier solution would be to migrate shards if you have enough shards on a server that migration is possible. I don't think there's a good framework for doing this yet. The final solution, depending on whether you're selling it or buying it, you might have a different perspective, is to deploy a SAN. So you get I/O pooling from the storage area network. Depending on your scale, this might not be feasible. And the final issue is that when you upgrade new hardware, you frequently don't replace the existing hardware. So the new servers have much more capacity than the old servers, and you need to figure out, do you need to run more MySQL instances on the new server? Somehow you want to bin pack so that old and new remains saturated. I/O capacity, to give a few more details on what I mean by we have enough, but we don't have enough. At the 50th percentile, we're using about 35% of the capacity for disk reads on the servers. And at the 95th to 99th percentile, those servers are too busy. So we have room for growth, I guess, on the average case, which is great, but we need to fix the outliers. Consistency. Consistency, and some of what Sam said in his talk prior to mine is relevant here. It's a very hard problem, and even he was speaking at the single instance, the single row level. For us, one part of the problem is with sharded MySQL, you're using multiple shards within a data center or a region. You also have to think about consistency between the master and the slave, and it's not just MySQL. You have caches, multiple caches in front of every database server. The caches are there to absorb QPS, but also to move the data closer to the access of the data and avoid network bottlenecks. And frequently, the existing solutions to this have semantics that are too constrained to be useful for complex applications. And just a brief picture, when you're using a website, you might be generating activity that inserts a row into a database, and then say to someone else, hey, look at this picture I took. Eventually, that person will access that data, probably from a cache that might be far removed from the original database. And somehow this has to be done in a coherent manner to avoid confusion. Online schema change is something that I think we've been running continuously, and there's one person on the team who does this full time. For us, it's throughput-oriented, so we occasionally disappoint users who expect a schema change overnight, but we do get the schema changes done. State management is a little bit interesting because as the changes are getting done, some servers fail and get replaced, and so the changes get undone. And eventually, we find all the servers and perform the change. For us, the big problem with this is that drop table stalls a server for about 3/4 of a second per table. And that results in a bad user experience. And so this has finally been fixed in trunk for MySQL, and we have a fix in progress for our branch. So I think eventually this problem will go away. Online migration, OLM, is something I don't think we've spoken about much, and I'd like to begin speaking about it and come up with a framework similar to OSC to make this possible. We want to move shards, migrate them between servers with minimal downtime. It's really a two-step problem. First, you copy the database or the shard from one and install it on the other server, and then you have to catch up on the changes that were done during the copy. There's a question of, do you want logical or hot backup to do this? If you're doing it via hot backup, I think with extra backup, they have optimizations to do per-table restores efficiently. And so in this case, we want to do all tables from that one shard rather than all tables on the server. Catching up replication, we've begun having discussions, although it isn't clear to me that there's a widely known solution for doing this. Flexible data model. MariaDB has dynamic columns. That's a start. I think a lot more work needs to be done. Some basic questions are, can the keys in the column be indexed? And am I wasting disk space by repeating key names? It's a big deal. We'd prefer not to use short key names to optimize for disk space because we want this to be readable and usable by people who might not have inserted the data and are trying to figure out what actually is in that column. Having this support would allow us to avoid some schema changes, but we need to be able to index it to make it a viable technology. Teper redundancy within a LAN. This is, I think, the missing feature, or killer feature, that you get potentially from a right-optimized store with a log-structured merge tree. The cost of maintaining a standby in terms of IOPS rounds down to 0 because you are applying sequential disk writes to maintain the data structure. The question is, can we get this in MySQL? I'm running out of time, so Harrison is probably snickering, as I tend to do. This is the most important slide for me. With a right-optimized tree, if I can get a free standby within a region, that would be a big reason to migrate. Node failure, can I afford a standby? If I had, HBase and HDFS do this, giving you the standby for free. I want to do the same, and I'm not sure yet whether I need an LSM within MySQL to do that. Can I get throughput that my hardware provides? My flash vendor gives me a card that can do 100,000 IOPS. Can an InnoDB absorb it? If it can't, do I get a discount on flash if I'm only using 10%? I don't think I'm getting a discount yet, so we need to get InnoDB to the point where it can do 50,000 IOPS sustained for a read-write workload, and it's not there yet. This is a pretty nice chart with what we've done at Facebook to get peak IOPS better than what you get from official MySQL. And I can demo on bogus benchmarks. Here I show 55,000. I've seen 65,000. It's a bogus benchmark, but it is a ceiling that I like to get. However, the storage capacity is a lot more than what I can get from InnoDB. So that yellow line is where we need to move InnoDB up to. 100,000 IOPS on a card, or even 50,000 IOPS, sustained on a complex workload. Thank you.